Hi, I'm Frédéric Hamel. I'm presenting an R7RS compatible module system for Termite Scheme, which was my master project I completed this year at the University of Montreal under the supervision of my director, Marc Feeley. Termite Scheme is built on top of Gambit Scheme. It's designed to simplify the programming of distributed system composed of a network of communicating nodes. It used the actor model present in the Erlang programming language, in which each node executes one or more actor, which are represented by threads, that is reacting to message received in their mailbox. One of the most common scenario in a distributed system is having node with different characteristics, such as different processor architecture, word width, type and version of OS. To execute a distributed application on the node, the code is either interpreted, compiled to a portable bytecode, or compiled to machine code, which is the best in which is the highest in terms of performance. Our approach address the problem of sending code message that contain code, in other words procedure, in a system composed of nodes with different characteristics when nodes are compiled to machine code. This problem is not easy because if all nodes were the same architecture and same instruction set, were homogeneous, it would be easy. You could just send the machine code over the network and it could work. Gambit offers some feature to help implement this system. It offers fast portable C code, which adapts itself to the machine and OS. It offers a way to serialize most of the scheme object, including procedure, closure, and continuation. It preserves the sharing and cycle in data type. This simplifies the programming of a remote procedure call by sending procedure and closure. It can also be implemented using ahead of time compilation and not sending procedure too. Task migration, because you can send continuation to the other node, which jump into this continuation. And not code update, which we can say is the main application of our module system. For this reason, I will show an example of an application using a code update, which will update the code of this node without restarting it. In the code update, one of the most important thing is that the code is not previously known by the destination node. This application is a little ping server which reply pong to when it receives a ping message. The main procedure that does the receive is the receive macro here, which allow a pattern match on the received message. The server loop over every message and it reply to all of them. When it receives a ping message, it reply pong directly to the client. So there's the ping and we receive a pong. If we want to add a code update to this little server, it's simple. You just add a new Endler inside the server. This is not yet the code update. but this enabled the code update inside our server. This message is simple. It will handle a message update which contain k, which is the continuation in the message that can be called, and so this code can jump into the new behavior. So we can have an updater which implement the new behavior of the Pong service. It's common to preserve the interface of the old behavior. So there's the ping, which now reply hello, which is a new behavior, and update, which is the same update as in the old behavior. There's also the migrate message. This is the message that allow migrating this behavior to another node. What it does is simple. When you send the migrate message, it captures the current continuation, the state of the this new server. The state of the new server, and then it's captured into K, which is sent to the server here, which is the destination node. This destination node then calls the continuation to jump in its new behavior. After that, if you send a ping request to the server, it will reply hello instead of Pong. So the code was updated without even restarting this service. This works well when interpreted, but there's issue when the nodes are compiled. The original of Termite Scheme allow unrestricted serialization, deserialization of interpreted code. The interpreted code contains the source code RST, which allows migrating most of the code easily. But when the code is compiled, the deserialization requires the receiving node to have the same compiled code as the sender. And the same compile code mean having each control point, which is symbolically can be an entry point to the function, a procedure, a return point. This is where the it can be. This restrict the limiting the this limit the changing of the code base during execution. Hinder the use of fast compiled code in RPC, though RPC can be implemented as ahead of time. So the only restriction is you cannot send a compiled procedure and have it executed on the server if the code is not available on the server. You only can execute all procedures that are already available on the server. And it precludes the use of a code update because the receiving node doesn't have the knowledge of the code you send it to. So the code update doesn't work in compiled program. Our solution brings a solution to this issue in the form of a R7RS compatible module system that install and compile the code on demand. What I mean by that is instead of having the code fail to deserialize the procedure because the code is not there, it will be able to automatically fetch that code and incorporate it inside the program to be able to access the code that was once missing. So the first thing is we host the source code on a VCS server such as GitHub, GitLab, which give a unique location on the network, and each version of a module can have a unique identifier. For example, the hello module on GitHub can be identified uniquely using this identifier. The magic is happen when we decide to embed the name of the module inside the name of the procedure that is defined in the module. This enables the deserialization process to locate, fetch, and compile the source code. This allows this is where the magic happens. Before, the procedure I would be deserialized and it would fail because I is not defined, and the code was not able to find I because I doesn't give any information where I is defined. By embedding the module name, now the deserialization process can extract the location and the version and download the right version of the module and then incorporate it inside the current process dynamically. The syntax of the module is the R7RS defined library. The name specified in the defined library doesn't mention the version. The VCS can handle that without automatically, so we don't need to specify the version. The defined library support all the standard R7RS declaration and more. The extensions are mostly for build option. As you can see, the last 5 are for build option. The namespace is the only one that is used to force a specific namespace on the defined library. Useful to implement scheme base, scheme write, and all the standard scheme library. Here's an example of a defined library that a use case of the defined library. We have the name here, the import statement, which in that case it imports the defined symbol in the scheme base and the hello module hosted on GitHub. It calls and implement the main function, which call the I procedure twice. So this is the cat module, and the hello module, what it does, it exports the I symbol. This gives access to the I symbol outside the library. It imports the defined symbol from scheme base and display with the name show in the current context. Display is renamed to show from the scheme write, and it defines the I procedure in its body. How this defined library is implemented in Gambit? It's implemented using some pre-existing form in Gambit. It uses declare block. Declare block is assume no block compilation, which means there's no set in other module to local variable. The namespace is used for as two usage in the implementation of defined library. It specifies the global namespace of the library, and it is used to import symbol from other library. When you import another library with the import library declaration, it will use the namespace form. Supply module declare the module name of the module that will be used. Daemon module register dependency on module. If you have multiple import, you may have multiple daemon module. There are some library that doesn't require daemon module, but I will show that in a following example. And all registered module are handled by the module loader that has been extended to download and compile the hosted module that are not currently installed on the node. Here's an expansion example, the cat module. It expands to a declare block, followed by the supply module and demand module. The supply module, you see the fully qualified name. Demand module, you have the registered dependency to the module hello hosted on GitHub, followed by the namespace declaration, which specifies the global namespace of the library and the namespace of the imported symbol from other library. Note that scheme-based is an example, a library example that doesn't require demand module because it only exports existing symbol from in the Gambit runtime system. After the namespace, it's followed by the other block, which is the implementation of the procedure, the begin block. The main procedure will be defined as gitlab.com/zoocat. It will be prefixed by the namespace of the library. I will be prefixed with the namespace of the hello library, which it's from. There are other features that are convenient but not essential to Termite. There's the feature whitelist for allowing automatic installation from safe site. It limits the installation from trust source to trust source. This is useful if you don't want to install from a non-trust site. You just don't add it into the whitelist, and the system will just raise an error when trying to download from this untrust source. There's a manual module management integrated into the interpreter to allow installation and uninstallation of module. There's optional version. It's not required to use version when importing a module. It's useful for development phase, but it's encouraged to use the version in the release of the module. It guarantees the stability of the module if the dependent module update. There's module alias, which can be defined. They are lexically scoped. Module alias allow aliasing a module to another module. So you can force a module to a specific version using module alias. You can use module alias to shorten the name of a module. The first case, it forced the version of the cat module to version 2. The second, it shortened github.com/fred to fh. So you just need to specify fh and the version. It will import the right version of the github.com/fred hello. It's interesting. Now we wanted to determine the performance gain achieved by our system. So we use 3 standard scheme benchmark of various code size and execution time when interpreted. We modified them to be executed through RPC. We used puzzle, scheme, and compiler of approximate size 4K, 40K, and 400K. The time it takes for an execution of puzzle time is approximately 1.1 second, 1 second, and 10 seconds. The machine used to run our experiment were at different OS. There were a Linux Mac OS and x86 ARM. So we had a machine that was ARM Linux, which was a Raspberry Pi, which is the slowest. We had x86 Mac OS and x86 Linux, which was the fastest, which is the fastest machine we had. It is water cooled, which gives it more numeric stability when running tests. The three execution scenario were interpreted. It's to test the original implementation of Termite, a way to compare to the original implementation. Steady state, if the module is not previously installed, but it's still required to be loaded into the program to be accessible. And first install, the module is not previously installed, so it requires to be installed, compiled, and loaded into the program. Here's the timing between ARM Linux and x86 Linux. We had a considerable speed up. The 4K was 7 times faster. The 40K was 17 times faster, and the 400K 22 times faster. So the more the code size was dependent on the speed up. This can be explained by the fact that when it's interpreted, the messages are much larger than when it's compiled, and also the execution time of compiled code is much faster. So we have a speed up in both network transmission and execution of machine code. There are other systems. The Go support VCS host supports installing module with version, but it's not a dynamic install. You can specify version of a module using the copkg-in syntax. Quick Lisp is you are able to install a module the same way we do in our system, but it's not tied to deserialization. The Erlang programming language offers code update. It's only manual, though it's only manual install. Nix offers similar idea of keeping multiple versions of module, though it's a system package management instead of a language package management. It's not used to manage a package that are for a language. The R7RS scheme has version, but it's not implicit for VCS. You have to explicitly specify the version in the library name. There are other module systems for Gambit, including Black Hole, Jazz Scheme, Gerbil, Scheme Sphere. None of these offer transparent serialization of compiled code and continuation needed for a code update. I will now demonstrate the feature of our system using a clock application written in Termite. This application displays time in terminal, updating its display every half a second. The first version of this application will have a bug, which we will fix using code update. Both nodes that will be used in this demonstration will run compile code. And will be represented by these two terminals. The above terminal will be the node A, which will run the clock application. I will start it now. The bottom terminal will run all the client that send message to the clock application. The message that the clock application support are set time zone to update the time zone to a new time zone, and update, which is the same update as seen in the ping pong example, which allowed the to update the code and enable the hotcode update using bypassing a procedure or a continuation. So let's change the time zone to -4, and then let's reset the time zone again. Now there's a trailing 5, which is really strange because I don't think hour is display using the minute use 3-digit, so there seems to be a problem, and this problem seems to appear when the hour passed from 2-digit to 1-digit. Let's fix that problem right now. This should do the trick. So let's test this new clock update to see if it works before updating. Note that Termite clock was compiled during the import. Seems to work. Let's commit our changes. And tag our changes. And push the tags. And let's run an updater, which will import the new version of our Termite clock and then send the update with the new clock thread loop. Let's run it. And now, as you saw on the node A, the new version of the clock is running. What happened is it was downloaded, compiled, and loaded into the program dynamically on demand, and the node never restarted. It's as easy as that. Thanks for your attention.